I am Atir Maher, your module leader. It is my great pleasure to welcome you to the world of learning new concepts and current trends. So let's start. All right, everyone, welcome. This is your complete guide to assignment 2 for SWE4304 databases. We're going to walk through everything you need to know from the technical stuff to the live demo to make sure you're totally set up for success. So let's jump right in. Okay, so here's our game plan. First, we'll look at the big picture of what this assignment is all about. Then we'll dive deep into the two main components, the technical files you'll submit and that all-important in-class demonstration. And finally, we'll wrap it all up with the critical rules and a final checklist so you can submit with confidence. Right, first things first, let's get our heads around the big picture. This assignment is really the logical next step from assignment 1. You've done the design work and now it's time to bring it to life. Now, this is a big one, so listen up. This assignment is worth a full 50%. That's half of your entire module grade. And that mark is broken down into two parts. 70% of it comes from the technical work you submit, and the other 30% is for the live demo you'll do in class. So what's the actual task? Well, you're taking that blueprint you created in assignment 1, and you're building it for real. You'll be using SQL to construct a fully working functional database for the Regent College London scenario. This table is super helpful because it really lays out the difference between the two assignments. Think of it this way. Assignment 1 was all about the theory and the design, your ERDs, your schemas, but assignment 2, it's all about practical, hands-on implementation. You're going from the blueprint to the actual building, and you have to show verifiable proof that it all works. All right, let's get into the main event, your technical submission. This is where you'll do the actual building and documenting. And remember, it's the largest part of your mark, making up a huge 70% of the grade for this assignment. Think of this slide as your ultimate submission checklist. You need to make sure every single one of these pieces is in your final package. You've got your SQL script, all your screenshots, 2 short reflections, a reference list, and that tools declaration. Don't leave anything out. The absolute heart of your project is going to be one single, well-commented SQL script. This file needs to have all the data definition language, the DDL, to create your tables. And it has to properly implement all your primary keys, your foreign keys, and all those essential integrity constraints, like not null, unique, and check. So, once your tables are built, what's next? You've got to fill them with data. You'll be using data manipulation language, or DML, for this. The requirement is to insert a minimum of 5 realistic sample records into every single table. This step is crucial because without data, you can't test your queries and prove your database actually works. Okay, now for the fun part, the queries. Your database isn't just a container for data. It has to be able to answer these 8 specific business questions. Your job is to write the SQL code that can handle everything you see on this list, from pulling simple information to performing more complex updates. And this right here is probably the most important rule to remember. Your work has to be verifiable. It is not enough to just write the code and say it works. You have to prove it. So for every single one of those 8 queries, you need to run it, double check the output is correct, and then take a screenshot to include in your submission. Okay, for your first reflection, we're shifting gears a little bit, moving from the practical code to the theory behind it. You'll need to explain why concepts like transaction processing and concurrency are so important for keeping data accurate and consistent in a real-world database, especially one that has many people using it at the same time, just like our college scenario. Your second reflection is all about your experience with this project. What technical hurdles did you run into? Maybe you struggled with a complicated foreign key, or a query was giving you trouble. You just need to briefly describe the problem you faced, and, this is the important part, explain the steps you took to figure it out and solve it. This is your chance to show off your problem-solving skills. Alright, you've submitted your work, but you're not done yet. Let's talk about the in-class demonstration. This is the live part of the assignment, worth 30% of your mark, where you'll show your working database to your tutor and, crucially, prove that you wrote the code. So what do you actually have to do in those 10 minutes? Well, here's the breakdown. You'll need to open up MySQL Workbench and navigate your database, explain your schema and constraints, run at least 2 of your complex queries live on the spot, and then be ready to answer any questions from your tutor. I know it might sound a bit nerve-wracking, but it's really your moment to shine and show off the awesome system you've built. Look, we know demos can be stressful, so to help you out, here's a simple 10-minute game plan. Following a structure like this will help you stay on track and make sure you hit all the key requirements. I really recommend practicing this flow a few times beforehand. It'll make a huge difference. Okay, we're on the home stretch now, but this last section is incredibly important. We're going to talk about the rules, academic integrity, and run through a final checklist before you even think about submitting your work. I really need you to pay close attention here because this is non-negotiable. This is a Category A assignment, and that comes with very strict rules. What does that mean? It means absolutely no generative AI tools are allowed for any part of this assignment. No ChatGPT, no Copilot, no Gemini, not even advanced rewriting tools like Grammarly. The code and the reflections you submit must be 100% your own work. And that leads right into a huge part of the demo, proving you're the one who did the work. The question is simple. Can you explain your own SQL? You should be prepared to answer things like, why did you use that specific foreign key? Or what's the purpose of this check constraint? Or talk me through the logic of your join in this query. If you wrote the code yourself, you'll be able to explain it. Okay, right before you hit that submit button on Canvas, I want you to pull up this checklist and go through it item by item. Seriously. Does your script run from top to bottom without any errors? Does every table have at least 5 records? Do you have screenshots for all 8 queries? Is your SQL commented? Are both reflections, your references, and the tools declaration included? Ticking these off one by one will help you avoid any simple last-minute mistakes. So let's wrap this up with one final thought. The secret to success on this assignment isn't some magic trick. It's just being methodical. If you build your database step by step and you test and collect your screenshots as you go, you're not going to have a mad rush at the end. You'll be totally prepared for both a technical submission and for a really confident, successful demonstration. So, right before you're ready to submit, I want you to ask yourself one final question. Look at your report and all your screenshots and ask, is my evidence so clear and so strong that it proves my work all by itself without me needing to be there to explain anything? If the answer is a confident yes, then you are ready to go. Good luck with the assignment, everyone. And remember, all the nitty-gritty details are in the official guidance documents on Canvas, so be sure to read those carefully. The contents of this video were put together by your database module leader, Athir Mahar. We are all really looking forward to seeing the fantastic work you produce.